There could be, and like I said, I don't know everything. My background is in ag and banking and real estate. So some of the terminology, I really want to at least get you the term and the concept and the definition so that you can pass your exam. And like I said, I'll do my best to help explain it. And if I need to, I'll go outside and try and round up some other answers for you so that you can have a good understanding. But it may come down to you're just going to have to remember that A plus B just equals C. Let's get into this. The art of surveying. We have surveying is measuring the size and shape of a parcel so that we can give it some boundaries. With the survey, it's going to be common that at least if your buyer or the buyer in the transaction is going through a bank, the bank's going to require that they get a survey done on the property. It's just part of the bank's procedures. They want to make sure that all those boundaries are clear and concise and that somebody's not encroaching on your property or even possibly vice versa. So that survey is just going to lay out where your boundary lines are. The meets and bounds system is the oldest known method for a survey or giving a description of where the boundaries are. And typically, how this works is that we have a point of beginning, and we're going to make this one a little monument sticking up out of the ground. And so that's our point of beginning. And we're going to go off of that in whichever direction the description gives us, and we're going to always close the box or close the gap in on that monument. So we'll start off, let's say, going 75 feet northeast. We're going to go 20 feet west. Let's say we go 150 feet south to southeast, and then we'll close the gap. Usually you'll see this type on something that's not a perfect square or rectangle. So we kind of have an odd shaped trapezoid there, and that's what that meets and bounds looks like. So it may be a monument, it could be a rock, it could be a tree that we're using as our point of beginning. At one point they would use bodies of water, like a lake or river. But what happens is that lakes and rivers, primarily lakes, will dry up, recede, or else they'll overflow. And so it wasn't as reliable as something like this, where we had a monument or something sticking out of the ground permanently. So it must have a determinable point of beginning, and it must end there as well. In 1787, we came up with the government rectangular system. There's an example of this in your handout and a larger example of this in your book on page 40. We introduce then with that rectangular system the meridians and baselines. Now when you look at that map, it can be a little bit daunting. You're not going to have to remember where the 37th meridian principle is or where the 33rd or 32nd baseline is in the U.S., okay? That's not going to be on your test. The simple fact that meridians run north and south, and baselines run east and west. If you look on page 41, this little illustration at the top of the page is going to be a huge asset for you for about 3/4 of this chapter. It's going to break down a lot of the different terms and thoughts that we are going to be discovering as we go through these pages. So you'll see on this page, at the very bottom of that picture, 3.6, we have a baseline running along the bottom, going east and west. And then going north and south, we have the sixth principal meridian. And that just so happens to be where this is located at for the purpose of this illustration. Before we get into dissecting this, a concept or a thought that you may see on an exam, and something that you probably, if you've driven the back roads of South Dakota going north and south, you've probably come across a time or two. And that is a correction line. A correction line is there to compensate for the curvature of the earth. We know the earth, thanks to Christopher Columbus, is not flat, it's round. And so every 24 miles, we have a correction line. So these correction lines, they run north and south of the baseline. And we're going to see, like for instance, we have a correction line here in Sioux Falls, and you may not even have realized it. So the correction line that we have here in Sioux Falls is 57th Street. And we see that it runs 24 miles north and south of the baseline. Another way to look at it is every 24 miles, there's going to be a correction line. So 24 miles south of this 57th Street, which is about in the Canton area, you'll see another correction line. 24 miles north, which is in between Baltic and Del Rapids, you'll see another correction line. And you still may be wondering how that looks or what that looks like. But let's take, for instance, Minnesota Avenue. Minnesota Avenue, when it hits 57th, what does it do? It curves, right? Cliff curves a little bit before 57th already. Let's see. Southeastern, or Sycamore, which is probably further over here, actually curves now before 57th. So if you're driving up and down, going again north or south on a back road, gravel road, you ever find that the road just dead ends? And then you have to go down a little bit to the left or right, and then it picks back up? Well, you just hit a correction line. That's what that is set in place for. Again, it's there to compensate for the curvature of the earth. Now, the next line that we have here is Chex. This is what you see on page 41. This check is 24 miles by 24 miles. You'll see that running up and down on the left side of the picture. It says 24 miles. And on the bottom of the picture, it says 24 miles. So this is a picture of a check. And you'll see that within that check, we have 16 boxes, or these are townships. So there's 16 townships in a check. And one thing that I want to point out to you is that with the check, if you read that, it says 24 miles going along the south of it, 24 miles going along the west side of it. It's a box. It's 24 miles by 24 miles. So for your test, if they're asking you the dimensions of a check, it's not 24 square miles. It's 24 miles square. Because it's 24 by 24. That's what a check is. It's 24 miles by 24 miles. And that's how we began to divide this country up into after we found the principles and meridians, so that we could break it down even further. And you'll see that in that illustration, and we'll continue to break this check down so that we can get right down to a very specific location, whether we're going to look at the specific location of a section of land, or 40 acres within that section, or an acre or even down to a city block. So we're kind of starting way out, looking at it from almost a global view or a view looking across the U.S., and then we're just shrinking it down to basically locating a city block or a house on that city block. The township, which you'll see is located within that, there's 16 of those located within that check on page 41. The township is 6 miles by 6 miles. So if I was to extract this township here, 6 miles by 6 miles. Again, it would not be 6 square miles. How many square miles is it? We just figured that out by taking the 6 miles by the 6 miles, multiplying them, and we get 36 square miles. So it's 6 miles square, like this check is 24 miles square, or 36 square miles. At the end of this chapter, on one of the last pages, there's actually on the bottom half of the page, kind of bullet pointed for you, some distances, some measurements, and we'll go through that too as far as pointing out some items that you could highlight for study purposes. Okay, before we go any further, let me put up on the board our township and our range lines. You'll see on the slide that township lines run parallel to our baselines, and our range lines run parallel to the meridians. So, in your book, again with that diagram on page, or that illustration on page 41, you'll see 2 townships that have been located. We have T2 North, R1 West, and then the bottom left corner you see T1 North, R4 West. So let's draw some of this out on the board. Before I get any further, let me darken our township line so you can distinguish that, and our range line. Okay, so if I was to mimic what we have in the book, I could put T2 North, range 1 West, and then this one over here, we'd have T1 North, range 4 West. So all I'm doing is just taking or copying what you see there in the book. So you will have on a test a question asking you to locate one of these or to give it an address. So what we're doing is the T is our township. And so we have, it says T2 North. I am 1, 2 townships north of the township line. It says range 1 West. I am 1 range west of the range line. So that's why it's 1 range west. Here I'm 4, 1, 2, 3, 4 west, and I'm only 1 north of the township. So if I was asked on a quiz what the description for this one would be, how would I fill that out? Township, 3 north, so we're 1, 2, 3 north. What was the other one? Range 3 west. 1, 2, 3 west. North, south, west, and east. Okay, how about this one? Right up here. Okay. So we're 1, 2, 3, 4 north, or 1, 2 west. Yep, you're right. Okay. What if I'm over here? What if I'm on this side of that range line? T2N because I'm 1, 2 north. R2 east. I'm 1, 2 east of that line. Good job. How about if I'm down here in this one? T2S. So I'm 1, 2 south. R1 east. It's like rye, but R1 east, right? What if I am, let me draw one more. What if I'm down here? So I'm 1, 2, 3 south. One, 2, 3 west. I think you're right. If you had, if your principal and meridian were in a different spot, it could interrupt this process. But this is to the extent that you're going to have to go for your exam. They're not going to have, if you have another check beginning over here or another check beginning down here, they're not going to get into those specifics. So you're going to always just go off of this single range line and this single township line. But that's a good question, because that can be the confusing part. That's it. It's just a matter of counting and making sure you know that this is west, east, north, and south. Right. Yep, exactly. Sections are the next portion, and this also can be an area where we have some confusion with. If you read the book, there's 36 sections in a township, 640 acres, because it's 1 mile by 1 mile. So the thing I want you to remember, because there's two different things you would see with sections. One is giving it a description. If it's the southeast corner of the northeast corner of the east half, which you might have read, that's one. The other one is counting. There's 36 sections in a township, counting those out. If they ask you a question like, where is township number or section number 16? You'd have to be able to locate that on a test. When I think of sections, my brain starts thinking that everything is going to be in opposites. Or everything is going to be not opposites. When I think of sections, I'm thinking everything is going to be backwards. I'll show you. If I have, so we have 36 sections. Let's just extract this township right here, okay? So I have 36 sections in a township. When I'm thinking sections, I'm going to be going backwards. So I start, if I have to number these out, and they're going to ask me something like, where is section 16? Or maybe they have like a box highlighted, and they ask you, what section is this? We start in the upper right, and number that 1. We're going to work backwards. It's in your book on that same page we've been looking at in the diagram. Huh? No, it's probably on 42. Yep, it's on page 42. There's just a smaller picture of it on page 41, but yeah, 42 has it blown up for us. So we're thinking sections. We're going to think backwards. So I start off with number 1 in the upper right. Is anybody that read ahead, do you know what I do next? 7 below 6. And go to the right. Good job. Same thing here. So that is section number 21. If I would keep snaking this around, I would end up with 36 down there in the bottom right. So what I'm doing is I'm starting backwards. I'm starting at the back, or on this side, instead of here, like how we're taught to read, going left to right. I'm going to start at the right, work my way left, and then drop down and just snake around. That's how I'm going to count out my sections in this township. We've numbered these sections. The next thing I want to do is we'll do 3 of them up here on the board, where I'll draw out some sections, and we're going to do some locating work. So for number 1, they want to find the southeast quarter of the northwest quarter. We're talking about sections here, right? So we're going to go backwards, just like we did when we were numbering out these sections up here on the board. So the first thing that we're going to do then is find the northwest quarter, and then we're going to locate the southeast quarter, and then we'll have our answer. So I have a section. This is 640 acres. It's 1 mile by 1 mile. It's a perfect square. So if it's a perfect square, and I want to find the northwest quarter, what should I do? Draw a line through the middle. Again down the other middle, which is this one. You're going to quarter it out, right? Very good. So now I have 4 quarters. If my directions run this way, where north is up, where is my northwest quarter located then? Top left. That's northwest quarter. Okay? The next thing I need to find is the southeast quarter. I've already located the northwest quarter. How do I find the southeast quarter? Draw another grid and a quarter it again. Okay, so now I have 4 equal parts. Where would be the southeast if I'm just looking in this little quarter? Bottom right. We agree it's right here. Okay. So number 2, a little bit longer. Southeast quarter of the northeast quarter of the southwest quarter. So first off, where am I going to start at? Very good. I'm working sections. I'm going to start backwards. Southwest quarter. Where is my southwest quarter here? Bottom left? So I've got that one down. My northeast quarter. What am I going to do? Quarter again? Were you giving me the blessing, or were you? Okay. So where's the northeast quarter for this one? Right here? Okay. Now, southeast quarter. And that would be where? Right here? Is that okay? Very good. All right. That's it. Just break it down. Okay. This is a south, not 5. So, north half of the northwest quarter of the southeast quarter. I'm going to throw one in there from left field. But the good thing is we don't have to worry about the north half until the end, right? Because we're going to work backwards. So at least we can get these two done. So the southeast quarter, I got to break it down or quarter it out. Where is my southeast quarter? Right here? Where I was pointing at already? That? Okay. So we got that one done. Northwest quarter. I'll quarter it again. Thank you. And then what? Right here? Top left. Thank you. Northwest quarter right there. Now, I want the north half. Perfect. Just cut it in half. That's the north half. Would you agree then if it said east half? I would go vertical then and just go on the east side of it. Okay? Remember, so sections. We're working backwards. How many acres are in a section? 640. So each one of these have 640 acres in them. One of the great things about math is that there isn't just one way to do the problem. There's only one right answer. That's another nice thing about math. There's absolutes. There's not gray area. It's this. But there's different approaches to this, and I'm going to show you one approach. There may be a different approach that works for your mind. If it helps, if you get the right answer with it, then stick with it, okay? But because I have been trying to make a point that with sections we work backwards, here's how we figure out how many acres are in the northwest quarter, or the southeast quarter, I'm sorry, of the northwest quarter, as we're going to work backwards again. And we're just going to divide 640 by this bottom number in the fraction. That's going to be our first step. So take 640 by, divide it by the number 4, and you get 160. Next thing is I'm working my way backwards. I take it and divide it by the next number, which is another 4. 160 divided by 4 equals 40. So that is how many acres that are located in that section, or in that southeast quarter of the northwest quarter. Now we have the southeast quarter of the northeast quarter of the southwest quarter. We're going to start again with this very bottom or very last number, divide it by that number 4. And those of you who are in the ag business, you just automatically know quarter section is 160 acres, right? So, but for mathematical purposes, we'll go through this process. We're going to divide it by 4. Again, we get the 160. What's the next number we're going to divide it by? 4? We already determined that that's 40. And then finally, 4 again. So what do you get? 10. So 10 acres in that parcel. Finally, Again, starting with 640 acres. Start at the very end with this 4. What's the next number? 4 again. And finally, what number? Good job. Divide that by 2. They have their calculator handy. 20. So 20 acres in that description there. So you will be asked either to locate it, like we did first, or tell them the number of acres. Okay? And remember, sections, I'm working backwards. The lot and block system is next. This is used by a subdivider, or we could say a developer, when they're going through a neighborhood and they're plotting out where they're going to put the homes. They're going to come up with kind of like a plat map or a lot and block system or plat that's going to lay them out. And I'll hand this out. I actually had 2, but somebody thought it was a handout, and so now I have 1. So just take a stab at it or look at it. That one's from Ronning, and it just basically lays out the entire neighborhood and shows you where all the boundaries are located. That's the plat. That's the record of how the subdivision is going to be divided. This is a survey. So we have the plat, which is the overall picture. I mentioned at the beginning of chapter 3 that if your borrower or bank or buyer is going through a bank, typically they're going to require a survey. And this is what the survey will kind of look like, except this one has other houses located around it. But what I've highlighted for you is the particular one that we're going to focus on, just to get an overview of what these look like, so that we all stay on the same page. So this is the Heritage Dells subdivision. This is just something I got off the web. They had to do a replat on this, so there were some boundaries they had to change. And so it just affected this particular area. And so what I want to point out to you that you'll notice on a survey, if you do get a chance to look at those surveys that your buyers have, I highlighted this area, and it's pretty small print. You got to get on the bifocals to see it, but it gives you the dimensions. If you would follow those lines that are highlighted, it'll tell you the dimensions, where the boundaries are located at. Pretty much your, like I said, your boundaries. And so that's what the the survey will say. The other thing I want to point out is the one that's highlighted in the middle. It says Lot 4A. If you look to the right, it says Lot 5A. You look to the right of that lot, or kind of up to the northeast, you'll see Lot 6. And so that's part of the legal description. When we see legal descriptions on the county website for something that's within the town or city limits, you're going to see first the lot. So this one's Lot 4A. And then the next one's going to be the block that it's located on. And this one is Block 6. And how I know that is if you look up at the top, it says Heritage Dells Replat, Minor Subdivision, Final Plat. And then below that, in smaller font, it says a replat of lots 4 and 5, Block 6. So we're in Block 6. So it would be Lot 4A, Block 6 of the Heritage Dells subdivision, or minor subdivision. That would be something close to how this would be legally described as. So each one's broken down into a lot, and we start off with that as our legal description. This applies more for the real world. You won't be tested over locating Lot 4, Block 6. What you would have as far as locating something is something like this, or the T2 North, Range 4 West. Those would be the things out of this chapter that you would need to be able to locate for a test purpose. The final thing on the slide is this vertical land description. Vertical land description is the description that's given to a condominium to identify it. You see on that survey, we have a legal description, Lot 4A, Block 6 of the Dells, or Heritage Dells subdivision. That's for one chunk of ground. What would they build on that? Probably a house. So when we're talking about condominiums, there is a different way to give a legal description. Because if I was to look at the actual buildings, let's say this is my condominium complex here, and each building has 9 units in it. The piece of ground that this is sitting on will have its own legal description, whatever it would be. Lot 7, Block 16, and so on. That's where the building's sitting. But each individual unit wouldn't be able to have a legal description in that type of format because we're just describing the surface or the land that we're looking at. And we need to have a description for this particular unit. Which is called an air lot. Remember we talked about air rights that can be sold? Well, this is actually suspended in air. It's its own separate unit. You can buy and sell condominiums. We're going to talk more about condominiums more in depth here in the days to come. But we need to have a legal description for this. I have a description for the land, but how do I get one for this? And we use what's called a datum. And you'll see that in the book. They use a datum. It's kind of like that point of beginning. It's a reference point. And from there, let's say this is our datum. It can either be at sea level or it can be some other place that's designated by one of the city officials or engineers. And it's going to, from this distance, basically give a 3D description of this particular unit based on this as my reference point. It's going to give this my vertical land description, or we can think of it kind of as a legal description, but it's not based on the surface or the land, because we already have one, like I said, for the buildings, but we need one for that suspended unit so that we can legally transfer it at closing. If you look on page 45, at the bottom of the page, there's land measurement and conversions. There are a few items in here that I want you to remember. In fact, if you want to highlight them, it'd be a good idea. Starting with number 4. Starting with number 4, a mile is 5,280 feet. That's really all I want you to remember for that. Why? Because you'll see a math problem where you're going to have to figure out certain mileage, not car miles, but distances, okay? And if you know that a mile is 5,280 feet, you're going to be able to get your answer correct. Just like the number 5, which is an acre. You will have a math question that says a farmer is selling a piece of ground and it's 875,365 square feet. How many acres is that? So an acre is 43,560 square feet. So to answer that question, you would take the total number of square feet that the farmer's selling, divide it by the 43,560, and that'll give you basically the amount of acres it is. Okay, so you will see that in the math question. In fact, coming up on your midterm, you may see a math question about square feet in an acre. So it's 43,560. Number 6, the section. These are the last 3 are ones that we've talked about. A section is 640 acres, and it's 1 mile square. Or we could say it's 1 square mile. It's both. 1 mile by 1 mile. A township has 36 sections, and remember, if we're going to number those sections out, we start at the top right and we work our way backwards and snake around. And a township is 6 miles square, not 6 square miles. It's 6 miles by 6 miles. So that gives us how many square miles? 36. And then finally, a check. A check is that 24 miles by 24 miles, or 24 miles square. And how many townships are in a check? 16. Good job. So hopefully that helped clean up or clear up some of chapter 3.